In this lesson, we'll explore the Fundamental Theorem of Calculus Part 2, also known as the Evaluation Theorem. This theorem bridges the worlds of differentiation and integration. The theorem states that if a function is continuous on a closed interval and there exists an antiderivative of the function, then the definite integral over that interval can be calculated as the difference between the antiderivative values at the bounds. This remarkable theorem provides a direct method to evaluate definite integrals by utilizing antiderivatives at the endpoints of integration. It establishes a crucial link between integration and differentiation, offering a powerful tool in calculus. Let's put this theorem into practice with an illustrative example. Consider the function f of x equals x squared. Our task is to determine the integral of x squared from 0 to 1. To solve this, we find the antiderivative of fx, which results in fx equals 1/3 x squared. By applying the evaluation theorem, we can now compute the integral of x squared from 0 to 1 by substituting the values into the antiderivative formula, yielding the result of 1/3. Understanding the role of antiderivatives is fundamental in computing definite integrals and comprehending the intrinsic relationship between differentiation and integration. Antiderivatives provide a profound method for solving integration problems effectively.